Hi guys, welcome back. Today we're going to continue our conversation about quantifying chemistry. So on page 81 in your notebook, go ahead and write down the DRQ for today. Go ahead and write the date, and then today's essential question is still how can we quantify chemistry, because we're still talking about that. And then the DRQ for today is, what is stoichiometry? Stoichiometry is one of those words that looks way more difficult than it actually is. But just go ahead and copy it down. And then today's class is really all about the definition of stoichiometry. Okay, so the word stoichiometry really just means the act of measuring using relative quantities. So it seems like a complicated process, but in reality, it's actually very simple. And it's something that we use in our regular life, our daily life, all of the time. We most often use the idea of stoichiometry, or predicting the amount of a quantity or amount of one reactant by looking at the amount or quantity of another reactant. We use this all the time in our real life, in the grocery store or in the kitchen, when we are trying to figure out, well, what would happen if I change the number or the amount of a specific ingredient? Or if I'm in the grocery store and shopping, how can I make sure that I have enough of what I need to make enough of the dish for everyone in my family? And so to help us just see exactly how we use stoichiometry in the kitchen, we are going to look or watch a little video of my 2-year-old son, Nico, making a sandwich.
Hi, Nico. I'm making a sandwich.
Okay, so Nico, what do you need to make your sandwich?
Bread.
And?
Mayo.
And?
One piece of cheese.
And?
Two pieces of meat.
Okay, so here are all your ingredients for your sandwich. Okay, you ready to make your sandwich?
Yeah, I'm ready. So I just put out these two breads.
2 breads.
Now, mayo. I added a knife.
Yep, you're going to do 2 mayos. Here you go.
One. Put it all here. Let's see with that.
Okay, that's 1. Got it? Okay. What comes next? Meat. How many meats?
3.
All right, put them on.
Whatever it is.
1. For the next one.
Oh, it's so mayo.
That's okay. 2.
This.
Okay, for the last one. There you go. Put it on. And what's the last part?
Cheese.
How many cheese?
1.
Okay.
Oh, it's going on. More.
There you go. Okay, go ahead. Go put your cheese on. Is it done?
Yeah. Pretty good.
How does it taste?
Good.
Okay. And that's how you make a sandwich. Okay, so what you can see from the video is that Nico is following a very specific recipe in order to make his sandwich the way that he likes it. Nico's sandwich requires 2 pieces of bread, 1 piece of cheese. It requires two scoops of mayonnaise and 3 pieces of meat. Now, if Nico wanted to change the amount of sandwiches that he wanted to make, he'd have to change the amount of or quantity of each relative ingredient in order to meet his goal. That is called stoichiometry. So let's take a look at that a little more carefully. If we were to turn Nico's sandwich into a chemical reaction, it would look like this. 2 bread plus 1 cheese plus 3 pieces of meat plus 2 helpings of mayonnaise gives us 1 sandwich. So how could we use that information and a bit of proportions to help us manipulate some of those quantities? So let's take a look at how to do that. And we'll go full screen so you guys can see both of my screens. Perfect. Okay, so over here, we're going to have the questions. And on this side, you're going to be able to see my work. Let me just get that set up a little bit for you. Okay, perfect. So let's take a look. So if Nico wanted to make 5 sandwiches, how many pieces of cheese would he need to do that? So in order for us to figure that out, we have to look at the known quantities we have and compare them to the ones that we are looking for. So let's start with what we know. If he wanted to make 5 sandwiches, how many pieces of cheese would we need? Well, we know that for every 1 sandwich, we need 1 piece of cheese. So some of you could probably answer this question in your mind or in your head, knowing that the relationship between sandwiches and cheese is 1 to 1. If I wanted to make 5 sandwiches, how much cheese would I need? It's pretty easy to realize that x equals 5 in that case, and we would need 5 pieces of cheese to figure it out. But they're not always that simple, okay? Let's take a look at mayonnaise, for example. For mayo, if we wanted to make 5 sandwiches and each sandwich requires 2 scoops of mayo, how much mayo do we need? Again, 5 sandwiches. We don't know how much mayo, but we are wondering, or that we know the relationship between mayo and sandwiches is a 1 to 2 relationship. Again, cross multiply and solve for x, we realize that we need 10 scoops of mayo in order to make that work out for us. We have to make sure we have enough at the store. Now, a lot of times we do these proportions in our head because we're just so used to them with recipes in the kitchen. But in chemistry, unfortunately, the numbers are not that simple. Most of the time, they're not whole numbers, and they're definitely not always even numbers. So it's very important for us to keep track of all of the little details so we don't get confused. We always need to make sure, number 1, that we are keeping track of our units. So keeping track of our units is essential in this case. And also that we take our time, we go slow, and we don't try to do too much in our head. And we really do utilize that calculator where it is necessary, especially when we start doing higher level algebra alongside this. So let's take a look at the next example. The next example uses a much more complicated number. It says, well, what if I was going to use 39 pieces of cheese? How many pieces of meat would I then need? Okay, not as easy to do in your head this time, right? For every 1 sandwich, I need 1 piece of cheese, and for every 1 sandwich, I need 3 pieces of meat. So how many pieces of meat do I need for 39 pieces of cheese? Yuck, this is a tough question. It becomes a lot more simple when we start to write it out on paper. So let's take a look at what I mean. We know the relationship of of meat to cheese. You can look right at our chemical equation to find it. Okay, for every 1 piece of cheese, we need 3 pieces of meat. So they have a 1 to 3 relationship. In other words, for every 1 cheese, I need 3 meat. Now, can I use that information to help me then figure out how many pieces of cheese I would need in order to use up, how many pieces of meat would I need in order to use up 39 pieces of cheese. So we just cross multiply and solve for x. The trick here, guys, is very important, that the units on the bottom always match and the units on the top always match. If you have cheese on the top over here, you need cheese on the top over here. If you have meat on the bottom, you need meat on the bottom. So now we just cross multiply and solve for x. We find that x is equal to 3 times 39, which is 117 pieces of meat. And that's it. And that's why we, this might seem a little bit familiar to you from like manipulating quantities in the grocery store when you're trying to follow a specific recipe. So for food and ingredients in the kitchen, it seems very simple. Of course, when we start to throw in some chemistry terms, we start to feel a little bit more uncomfortable with the information, but it's the same math skills that are required. So let's go ahead and take a look at what I mean by that. Let's look here. Let's imagine that we have some chemistry involved. Now, instead of looking at the number of pieces of cheese or pieces of meat that we're talking about, now we are looking at the number of moles of something. And this is why that value of a mole is so important. Because as it turns out, in a chemical reaction, when we see these coefficients at the beginning, what we're using those coefficients are is they tell us how many moles of each thing is required. So this question asks, how many moles of HCl, so how many moles of HCl are required to produce 5.3 moles of H2? And so what we need to look for is a relationship between HCl and H2. Now, the relationship between HCl and H2 comes from this chemical equation. 2 moles of HCl will give us 1 mole of H2. In other words, for every 2 moles of HCl, we get 1 mole of H2. And so this question is asking us, well, how many moles of HCl will produce 5.3 moles of H2? And again, let's remember, the units on the top have to match and the units on the bottom have to match. So if you're wondering, well, where do I put that number? You make sure the top matches, bottom matches, and you're golden. Again, now we're going to cross multiply and solve for x. So when we cross multiply and solve for x, we'll find that x is equal to 2 times 5.3. We find that we would make 10.6 moles of HCl. Okay, let's try another example. What if 3 moles of Fe? How many moles of HCl are going to be needed? So let's take a look at that, all right? So if I have 3 moles of Fe, how many moles of HCl would be needed to use that all up? So let's look again at their relationship. So from the chemical formula, we see that relationship that if I had 3 moles here, I want to know how much of this I will need. So what is their relationship? They have a 2-to-1 relationship. For every 2 moles of HCl, I need 1 mole of Fe. So they have, for every 1 mole of Fe, okay, I need 2 moles of HCl. So what if I had 3 moles of Fe? How many moles of HCl would I need to use that all up? Again, cross multiply and solve for x, and what you would find is you would have 6 moles of HCl that would be needed. Okay? So regardless of the chemical formula, when we are talking about a mole-to-mole ratio or a mole-to-mole relationship, we are looking at the chemical formula or the chemical equation at the top to help us figure out what it is by looking at those coefficients. And then we're just using some proportions here to help us figure out or make some predictions about what would happen if we needed a specific amount or if we used a specific amount. So for today on page, I think it's 82, or no, it's page 80 in your notebook. I have a couple problems for you to try to work on attached to this assignment. And you're just going to go ahead and see if you can calculate how many moles would be needed or how many moles would be produced if we manipulate some of the quantities. You guys can do that on page 80, snap a photo of it, and upload it to Classroom. Have a great day, guys.